Japanese scientists have created a robot duplicate of the country's Minister for Digital Technology, Taro Kono. The official's robot twin is part of a research and development project led by Professor Hiroshi Ishiguro of Osaka University. The research is also part of the Cabinet Minister's project. It was developed to test the possibility of conducting social events remotely. The 175 centimeters tall robot has 52 movable parts, including on its face, arms, and waist. The cybernetic avatar of the Japanese minister has yet to be tested. During the trials, the avatar will interact with people, deliver speeches, and scientists will attempt to determine whether people perceive the avatar in the same way as the minister. The minister himself can remotely control his robot clone. This allows him, among other things, to participate in public events without the need to be physically present there. Such a robot is needed by scientists for a series of studies on people's attitudes toward such copies, and whether such a robot can eventually replace a human in various fields of activity. Researchers are convinced that a cybernetic avatar will increase the efficiency of economic activities, especially if one person manages more than one cybernetic avatar, performing various tasks remotely. Oryx Rentec, a Japanese tech rental agency, and a branch of the well-known Oryx car rental agency, has announced the launch of a robot rental service called RoboRen, featuring an android named Mirai Madoka. It serves as a multilingual secretary, proficient in English, Chinese, and Japanese. Bearing resemblance to Toshiba robots, Mirai Madoka may have been co-developed by Toshiba and A-Lab, or exclusively by A-Lab based on Toshiba-like specifications. The robot is displayed at the Oryx Rentec showroom named Tokyo Robot Lab near Tokyo. However, due to its commercial nature and focus on potential renters, access to the showroom is restricted to the general public. Nonetheless, the showroom offers an intriguing array of robots for rent, including Mirai Madoka and various industrial and collaborative models. With its ability to move its eyes and lips, Mirai Madoka exudes beauty and elegance with its long hair. R-Fight, a fighting game featuring robot suits, was demonstrated at a preview event for Sushi Tech Tokyo 2024 in Tokyo's Chiyoda Ward on April 9, 2024. The previous robot suits by Skeletonics, exoskeleton suits, had a strong showing element, such as demonstrations at events, but R-Fight is considered a new concept of technosports using the robot suits. When you battle each other using weapons, a sensor embedded in the suit detects damage, creating the sensation that you are participating in a fighting game. This time, R-Fight was created not by Skeletonics, but by the Superhuman Sports Project. Based on human augmentation engineering, it envisions a human-machine form of sport, where superhumans with abilities surpassing human physical capabilities compete against each other. Today, there are many types of esports and VR sports, but for people who want to sweat in person, something as straightforward as R-Fight could be important. In recent years, the field of robotics has seen tremendous advancements, with applications ranging from manufacturing to healthcare. Now, thanks to Dino Robotics, a groundbreaking software has been developed that allows robots to understand and interact with their cooking environment. By using artificial intelligence, AI-based object localization, and 3D image processing, these robots are capable of accomplishing complex culinary tasks, such as seasoning and cooking a steak or preparing a salad with fresh ingredients. The integration of robotics into the culinary world opens up a realm of possibilities. Traditionally, cooking has been considered a skill that requires human intuition, creativity, and experience. However, with the introduction of AI-driven robotics, we are witnessing a paradigm shift in how meals can be prepared. One of the key features of Dino Robotics software is its ability to recognize and understand various objects in the kitchen. Through advanced algorithms, the robots can identify ingredients, utensils, and even cooking equipment. This capability allows them to perform tasks with precision and accuracy, ensuring that every dish is prepared to perfection. Not only do these robots excel at following recipes, but they can also adapt to different cooking environments. By analyzing the surroundings and making real-time adjustments, they can account for variations in temperature, humidity, and other factors that may affect the cooking process. This adaptability ensures consistent results and enables robots to handle a wide range of culinary challenges. Engineers from the Unleashed project recently presented the kitchen skills of the trainable home robot Aloha with open source code. By the way, engineers from Google DeepMind are also involved in this. Now they are teaching robots to tie shoelaces, hang laundry, and repair other robots. At each station, they are fully autonomous. Moreover, when engineers taught one bot to hang a shirt and threw a sweater into its workspace, it generalizes the knowledge and tackle the new task without prior training. But the most impressive demonstration was the replacement of fingers on another robot, evoking memories of Skynet, especially considering that we are about to be introduced to a general artificial intelligence. What do you think about this? Should robots repair each other themselves, or is it better to trust humans? Engineers from the ETH Zurich laboratory conducted a test of a three-legged hopping robot for asteroids in a weightless environment. However, not yet in space but aboard an airplane. The space hopper is being developed to move across the surface of asteroids and other bodies with extremely low gravity, where the robot will search for valuable minerals. The current prototype of the space hopper consists of a triangular body made of aerospace aluminum with hinged legs at each corner. Each leg, in turn, has knee and hip joints. Two motors move the thigh using a differential drive mechanism, while a third motor controls the knee. The robot is omnidirectional and equipped with deep learning-based software. It is responsible for coordinating leg movements, maintaining proper body orientation during flight, and executing controlled landings at predetermined locations. During weightlessness tests, the robot hopped in a specific direction and attempted to maintain the correct body orientation in the air. The startup Nuni has unveiled an upgraded version of its walking chair, the Chairless Chair 2.0. The Chairless Chair was originally developed back in 2014. It is an exoskeleton for the lower body that does not impede walking but provides support when sitting. The Chairless Chair supports the legs of a person, such as a factory worker, who is required to spend a lot of time in a static vertical position. The design of this walking chair easily attaches at various heights from the floor, allowing the worker to relieve joints from harmful strain. It is anticipated that the use of this development in the future could help increase labor productivity and preserve the health of particularly mobile employees who need to occasionally work at terminals or multiple workstations. Among the improvements of the new model are a 25% weight reduction, a thinner and more comfortable design, lighter, more flexible, and reliable shoe connections, as well as an increased user height range. It can be adjusted for users ranging from 1.5 to 2 meters tall. As an additional bonus, Nuni claims that sitting on this device helps strengthen back and thigh muscles. The Dutch startup RoboRen Marine Technology showcased the Waste Shark unmanned surface vehicle at the CES 2022 exhibition, a floating drone designed to remove harmful plastic waste from the water and return it to shore before it can cause damage. Waste Shark is an automated aquatic drone that can be operated manually or fully autonomously along a predefined route using waypoints for navigation in a specific body of water. The device features a detachable basket where trash is collected, which can be easily removed, emptied, and then put back in place for further use. In addition to collecting surface debris and biomass, Waste Sharks can be equipped with sensors, providing users with additional benefits by receiving real-time data from relevant bodies of water through a 4G data transmission portal. Its capacity is about 180 liters of garbage per load, which corresponds to approximately 500 kilograms per day of plastic and biomass with one daily load. Furthermore, the drone uses advanced battery technology, enabling operation on water without emissions and without increasing water pollution. This makes Waste Shark one of the leading solutions in the fight against plastic pollution. Write in the comments which of these inventions you like the most. Subscribe to the Caro Show channel to stay tuned for our upcoming videos and check out our previous episodes. Goodbye.